Hello, everybody. Welcome to Gillis Education's workshop on fractions, decimals, and percentages. My name is Abby Berkheimer. I'm a tutor and consultant at Gillis Education. And today we're going to go over some practical math, and we're going to make it a little bit more simple. We'll tackle some real life scenarios that require these skills, and we'll go ahead and dive in. So, we are going to be working on our first worksheet, which is the candy store math. We're going to use some of these items on the shelves, and we're going to answer the questions below. So, to get into it, what I like to do first is read through each of these prices so that I know going in if the question asks about the donut or the cupcake or whatever it may be, I know exactly what I will be looking for. So, for question number 1, it states, you want to buy the donut. There's a 20% discount on it. Calculate the discounted price. So for this one, when we talk about discounts, one thing that trips a lot of students up is what a percentage discount is. So a discount is going to be basically a fraction, a part of a whole, and we're going to move the discount, the percentage, into a decimal. So when we talk about a 20% discount, that's 20% of 100. So there are two different ways to get the decimal for this percentage. So the first one would be dividing 20 by 100, and we get 0.20. The other way that we can do this is just by moving the decimal point in 20% over 2 to the left. So if I have, for example, 20%, which is 20.00. What I would do then is I would move the decimal point over 2 to the left. So I would go 2 to the left and get 0.20 as my decimal point. So once we have that discount in decimals, we are going to multiply it times the price that we are trying to discount. So in this case, it's going to be the donut right here, which is $2. So we are going to multiply it times 2.00 because dollars represent a whole. So we have 0.20 times 2.00. And we're going to do that math real quick, and we should get 0.40 as our sum. So we'll have 0.40 right here. But we're not done. We still have to subtract this from the original price. So we're going to take this discount right here, and we're going to subtract it from our original price, which is $2. So we're going to take $2, which again is 2.00, and we're going to subtract 40 cents from it, 0.40. A lot of students struggle with remembering what what the dollars represent. I like to think of them as fractions. So we're going to take 2 minus 0.40, and for that one, that is going to give us $1.60. So 1.60. And so that will be our answer for question number 1. It'll be $1.60. So we're going to put that one right here. For question number 2, what we're going to do now is we're going to talk about the difference between a debit card and a credit card. This is something that's really important for real-world applications for students. A lot of students struggle with understanding these more abstract concepts like debit versus credit. So there's a distinction between debit and credit. A debit card allows you to spend money directly from your bank account, deducting the amount immediately from your balance. On the other hand, a credit card is going to enable you to borrow money. And it lets you borrow money up to a certain limit with the expectation that you pay back the money later. And that's often going to come with what's called interest. So, interest is a set percentage that you will pay in addition to the original amount. So, for example, if you have $100 that you spend on credit with a $7 interest or 7% interest, that would eventually be $7 extra that you are going to pay in addition to the original amount that you've borrowed. And so now I want to go over what some of the benefits and disadvantages are to credit versus debit. So characteristics that are the same for both debit and credit are going to be that it's convenient and it's widely accepted. There's also fraud prevention, it's secure, and it can replace cash in a lot of instances. However, there are some benefits or advantages specific to credit. So, credit is great for emergencies. It can help improve your credit score, and you also sometimes have extra perks on it, like grace periods or reward points. Next, there are some certain disadvantages. One of them being that you end up paying more on credit with interest included than you would if you just paid debit. You could be hit with late fees, high interest rates, and a lower credit score if you do pay payments late or miss a payment. You could also overspend and have unnecessary debt because of that. Next, we have debit card benefits or advantages. It's easier to keep track of what you spend on a debit card. You can get cash at ATMs. You have a PIN for a lot of debit cards, and you won't pay interest on your purchases. However, there are some disadvantages that go along with this as well. It can be declined if you don't have enough money on your account. So, if you are running low in your debit account, you can't spend over what you have in that. So, now we're going to explain the difference between the two. So, to put it simply, the difference between the two is that a debit card is linked directly to your bank account and deducts money when used. A credit card allows you to borrow money up to a certain amount and you repay it later, oftentimes with interest. So now we're going to move on to number 3, and we're going to go back to the items in the candy store. So in number 3, it states, you bought the top row of items on debit and the bottom row on credit. How much did you spend total? So for this one, this is going to be an addition problem, counting first the first row and then the second row and adding all of them together. So to do this, we're just going to add together the totals. So we have 50 cents, which is 0.50 for the gummy bear. And then we're going to do an addition sign because we are adding the totals together. We're going to do plus $1.50, which is 1.50 for the gumdrops. And then for the donut, we are going to have plus $2, which is 2.00. Let me see if I can move this a little bit. Okay. And then we have plus $2 again for the cookie. And then that is the top row. So we're going to add all of these together. I'm going to try and make these smaller so they fit in one row, if it'll let me. I don't think it's going to let me. But we're going to add all of these together. So 0.5 plus 1.5, I like to break these up a little bit and add the first two. That's going to be $2. So let me take this and use my marker. That's going to be $2 when you add these two together. $2. And then when you add the last two, that's going to be $4. So now all we have to do is add together. Let me fix that. Now all we have to do is add together these two numbers, and we get $6 for the top row. But we're not done because we still have to add the bottom row. So the bottom row, I'm going to do the math off to the side on the right-hand side over here. That's going to be $3. And then plus $1.25, which is 1.25. And then plus 75 cents, which is 0.75, because again, anytime we're talking about money, we're talking about parts of a whole, the whole being $1. And then we have $5. So we're going to add all of these together. And we're going to do the same thing by breaking these up. So we see that the 3 and the 5 are already whole numbers. So we're just going to leave those alone. Instead, for this one, we're going to add together the $1.25 and the 75 cents. So that is going to be $2. And we can add it to the $3 that we have at the top, and then the $5 that we have at the bottom. So we have 3 plus 2 plus 5, which is $10. And we're going to add that to our original $6 that we had from the first row. And so when you add 10 plus 6, that is going to be $16 even. So it comes out to 16 because when you add all of the rows together, the sum equals 16. However, on credit, if it were to ask you about interest, you would have had to multiply the second row's amount by whatever the interest is. In this case, it didn't ask you, but just remember that credit does often have interest. All right, so I'm going to erase some of this work over here so we have more room to work. And then we're going to move on to the next problem. So it says you have a $7.99 coupon for your shopping. If your total bill comes to $21, how much will you pay after using the coupon? So again, this one is just going to be a subtraction problem. And all you do for this one is $21 minus $7.99. And so what we end up having to do here is a little bit of a more complicated subtraction problem. But when you subtract these $7.99 from 21, you get $13.01 as your answer. So I'm going to write $13.01 right here. And I forgot to write the sum for the third problem as well. So that one was $16. All right, and then now we're going to talk about savings. So in a savings account, that's money set aside for emergencies or a rainy day fund, and it's money that you're not actively using. So it says that you have $213 in your savings account. You withdraw to $28.79. How much money is left in your account? So that is going to be another subtraction problem where you take your original number, which is 213, and you subtract 28.79, which is $28.79. And so once you do that, you should be left with $184.20. 21 cents after you do the subtraction. And so after that, we have number 6, which is going to ask about converting fractions to decimals. So to convert a fraction to a decimal, you're going to divide the numerator by the denominator. So let's take 1/4, for example. So for 1/4, you are going to take 1 and divide it by 4. And so when you do this, you should be left to get 0.25 because that fits 4 times into, it fits 4 times into the number 1. So I made a mistake. 0.25, not 0.24. 0.25 fits 4 times into 1. So for that one, you're going to write 0.25. So the next one, you're going to set it up the same way. You're going to set it up by dividing 2 into 5. So 2 divided by 5 is going to be 0.40. So when you have 2 divided by 5, you'll know that it is 0.40. We can move that right there. And then the same thing for when you have 3 divided by 8. I'm going to make some room real quick so I can do this. There we go. So you are going to take 3 and you're going to divide it by 8. And I'm going to erase this math up here because we no longer need it. So when you take 3 divided by 8, you are going to get 0.375. And that goes into the third blank right here, 0.375. And I'm going to have to make that a little bit smaller so it fits. There we go. And then the last one is 2/3. So you're going to take 2 and you're going to divide it by 3. And for that one, you're going to come out with 0.667. Once you divide 2 into 3. All right, so now we're going to talk a little bit about savings, debit, and transfer funds. So we talked a little bit in question number 5 about what savings is, but it's money set aside for future use or emergencies. Next, we have debit, which is a transaction that takes money out of a bank account. And then transfer funds are going to be moving money from one account to another. And that is it for the candy store math. So I'm going to erase all my work over here so that I can move on to the next worksheet. All right. That is good enough. Let's erase a little bit more. Now we're going to have multiplying and dividing fractions. So I have 2 different examples of this. I have fraction times fraction, fraction divided by fraction, and then another fraction times a fraction. So with this worksheet, you will actually get an answer key that also explains everything that I am about to go over. But for this one, like I said, we're doing fraction times fraction first. So your first step that you're going to take in this is multiplying the numerators. So we have a numerator, which is the top number in a fraction. And in the first set, it's 3. And then the numerator in the second set is 2. So we're going to take 3 times 2. And when we do that, we get 6. So we know that the first, the numerator in our answer is going to be a 6. So I'm going to put a 6 right here, and I'm going to make it a little bit bigger because we have room in this box. So we have a numerator of 6 right here. And then we're going to then multiply the denominators. So when we multiply the denominators, we get 4 times 5, which is 20. So we're going to put a 20 in the bottom of this. However, we're not going to leave our fraction like this because we need to simplify it to its lowest terms. So to do that, you are going to divide these numbers into their most simple terms while still remaining a whole fraction. So what you're going to do for that is determine how much you can divide this fraction for it to make sense. So we know that we can divide it by 2 at most because that's the only 2 is the only number that can go into both the numerator and the denominator. So our fraction then becomes 3/10 in its simplest form because again, we only have 2 that could go into 6 and 20. So next we're going to do fraction divided by a fraction. So the first step in this is actually going to be keeping the first fraction right here, which let me go ahead and circle that. You're going to keep the first fraction the way that it is. However, you are going to swap the numerator and the denominator in the second fraction. So your new problem becomes 2/5, or I'm sorry, 2/3, not 2/5, 2/3 and 5/4. And instead of having the division symbol right here, you're actually going to change that into a multiplication symbol. So instead of having this division symbol, we're going to cross that out and we're going to make it a multiplication symbol. And then you're going to follow the same steps that you did in this top problem. So it's now 2/3. Oh, let me fix that. It's now 2/3 times 5/4. So 2 times 5 equals 10. And then we're going to multiply the denominators now. And we're going to do 3 times 4 equals 12. So we have the fraction 10/12. However, we know we can simplify this still. And we're going to, again, look for the number that can go into both the numerator and the denominator. And when we do that, we get 2. So we're going to divide each of these by 2. And instead, we will have the fraction 5/6, which will be our answer that we put right here. So 5/6 is our answer for this one. And then we have another multiplication problem right here. So all we do for this one, again, is multiply the numerators together. So 1 times 3 equals 3. And then we multiply the denominators, and we get 2 times 4 equals 8. And this fraction becomes 3/8. And we know we cannot simplify that anymore because there is no number except for one that will go into 3 or 8. So our new answer becomes 3/8 for this one. So fractions are going to be useful for a lot of everyday tasks. The biggest one that I like to think of is going to be like baking when you have a recipe. Sometimes you might have to simplify fractions in order to have the right amount of a certain ingredient. Like if you had a recipe that fits 20 people, but you only need it for 10 people, you would have to divide each of the fractions used in that recipe. So you would have to know that if you have, a half cup of olive oil, for example, that you then need to make it a quarter cup of olive oil if you are splitting your recipe to fit 10 people versus 20 people. So now this one is going to be our science fractions worksheet. It's also available, as are the previous two worksheets. So in a science class, 5 students are conducting an experiment to measure the density of different liquids. Each student has a container marked with various fractions representing the volume of liquid they need to pour. How much liquid did they pour total? You're going to color in the beaker with how much liquid they poured and write the fraction next to it. So worksheets like this are really important for students that are just beginning to learn about fractions because it helps them see fractions as parts of a whole. So each of these beakers fills up to 8 different lines. And so when students do worksheets like this, they're able to have a visual representation of what fractions might look like in real life scenarios. So for this first one, it says Adam pours 1/8 of a liter of water into his container. So what students will do is they will go in and they're going to color in 1/8 on here. So we know that this fraction or that this beaker by counting has 8 parts. So all they have to do is fill in 1/8, and then they're going to write out the fraction just like this on the little or in the little box that they have. So 1/8 looks like this in the beaker. Next, it says Bella pours 2/8 of a liter of oil into hers. So we're going to take a different color and we are going to fill in 2/8. So up to the second line right here to represent 2/8. After that, we are going to put in our answer box 2/8. For the third one, it says Chris pours 7/8 of a liter of vinegar into his container. So again, we are going to take our marker or whatever utensil you would like to use, and you're going to color in up to 7 of the up to the 7th line. So 1, 2, 3, 4, 5, 6, and then 7. And that represents 7/8. For the fourth one, it says Diana pours a full liter of alcohol into her container. So we know that a full liter is going to be 1 whole. So we're going to cover the entire thing. So we're going to take it and we're going to color in all of this. And hopefully you'll stay on the lines better than I did. So 1 whole would be 8/8 because there are 8 different parts to this fraction, and we colored in all of them. Next, Emma carefully adds 1/8 of a liter of syrup into her container. We know we're just going to color in 1 part of the beaker to get 1/8. And we're going to write it right here. But now we have to total up all of our fractions and see how much liquid did they pour total? So that's what the worksheet says right here. How much liquid did they pour total? So where it says total, we are going to do some math and figure out how much they poured total. So in the first one, Adam poured 1/8. So we are going to write 1/8 right here. And then plus 2/8 because that's how much Bella poured. Plus 2/8. And then plus 7/8 because that's how much Chris poured. And then 8/8, which is 1 whole. And then finally 1/8 again. So we have 1/8 plus 2/8 plus 7/8 plus 8/8 plus 1/8. So the way that we are going to solve this one is by adding all of the numerators together. We see that each of these problems has the same denominator. So we're not going to worry about the denominator for right now. What we're going to do is add together 1 plus 2 plus 7 plus 8 plus 1. So when we do this, that is going to give us our numerator before we simplify everything. So 1 plus 2 plus 7 plus 8 plus 1 is going to be 19. But 19 over 8 is not how we are going to leave this. Because remember, 8 is our denominator that we started with. We're going to need to simplify this. And we're going to need to see how many times 8 goes into 19. So when we do this, we're going to go like this. And then we're going to put 8 and 19. So 8 is going to go into 19 at least twice. So we're going to do 2 up here. So it goes into 19 twice because 8 times 2 equals 16. And then we need to figure out how much we have left over because we can't fit 8 in it any more times. So we're going to subtract 16 from 19 and get a 3. So we have 3 left over. So we know that our total is going to be 2 and 3/8 as our fraction. All right. And then that is it for our worksheets and our worksheet problems. I'm going to go ahead and I'm going to stop sharing. All right. And if you have any questions about how to solve any of these, all of our worksheets have a page with the answers and how to solve for each of these problems that we went over today. Fractions are going to be really important for students to understand as they go through school. Fractions are used in almost in everyday activities, and they are really important for students to understand and apply to their own lives. So if you have any questions about any of the things we went over today, you can drop a comment, and you can also check out some of the resources that we have available on our website at Gillis Education.